So here we will learn how to create a heap for given elements. In the previous video already we have learned how to insert one element in a heap. So using that same basic idea, I will extend it and show you how to create a heap. See, here I have an example. This is a max heap with 3 elements, 30, 20, 10. 30 is greater than these two. So yes, it's a max heap, and also it's a complete binary. It is there in the array. So this is in heap. So these 3 elements are forming a heap. Then this insert function, this procedure we have already seen how it works. If I insert a new element like 40 here, then I can arrange this element within these elements to form a heap of 4 elements. So this will try to adjust by checking with the parents and adjusting the element at a proper place. So we know well how it gets adjusted. I'm not going to adjust it now. We know how it works, right? It compares with the parent and adjust it. So for one element it works. Now let me extend the idea. I will insert 40, 15, 12 and 25. See, this portion is a heap and these elements are not in heap. Heap is ending till here, only 3 elements. What about these elements? They are present in the array but they are not in heap. So is it possible to insert all these elements one by one? Yes, I can insert. First insert 40, so heap size will become 4. Then insert 15, heap size become 5. So one by one I can insert all the elements in a heap. So it is just like from this side include an element on this side to form a heap. So it means from right hand side include an element in a left hand side heap. So one by one I can insert the elements. So this means that these 3 elements were also inserted like that only. Yes. So then how many elements will be there initially in a heap? One element. The very first element is heap. So this is the idea. One by one we insert the element from right hand side to left hand side and go on creating a heap. So we don't need any extra array for creating a heap. Within an array only elements can be adjusted to form a heap. So that's how this is called as in place heap creation. When it is happening inside same array, we call it as in place. So heap can be created in place. So I will take few elements and I will try to show you how a heap is generated. Now let us see the procedure for creating a heap. See, already I have 7 elements and the first element is in heap. Obviously, if nothing is in the heap, then at least first element is in a heap. Ignore all of them, just one element, nothing to compare with anybody. So it is heap, right? The font size I kept it small because I need more space. Now let us insert second element in a heap. So the next element that I will insert is 20. So insert 20 in a heap. So when I insert 20, diagrammatically if you see 10, 20 come as a left child of this one and 20 is greater than 10. So 20 should move up and 10 should come in its place of 20. Then how it looks like in an array, 20 will be here and 10 will be here. Now till here it is heap, then remaining elements are as it is. This comparison we can see it here that 20 is compared with the 10. So 20 goes here and 10 comes to in its place. So this is the result after inserting 20. Now next element is 30. So third step I will say insert 30. So diagrammatically how it looks like. Right now tree is 20, 10, 20 and 10. So 30 is on this side, right? So 30 is newly inserted. Compare with the parent. So 30 is greater than the parent. So 30 goes to the parent's place and 20 will come in the place of 30. So this is moved or swapped. So this has happened when we were inserting 30. So it means 30 was compared with the parent. So this is index 3. 3 by 2 is 1. So it was compared with this one. So what is the resultant array? Elements in a heap are 30, 10 and 20. Heap is still here and the remaining elements 25, 5, 40 and 35 are as it is. So this is after inserting 30. Next I have to insert 25. So insert 25, right? Inserting 25 means where 25 will come? 25 will come as a left child of 10 as per complete binary order. 30, 10, 25, 25, newly inserted. Now newly inserted, compare with the parent. So this is greater than parent. And more with the parent. No, this is not greater than 30. So it will be swapped with a 10. So the resultant tree will be 30 is not modified. At this place comes 25 and here is a 10 and this is 20. How it is done in an array? 25 is index 4, so 4 is compared with the 10. So yes, 25 is greater than 10, so it is swapped. And further, if it is compared, this is not greater than 30. So it is swapped only with the 10, so this is the result. So how the array looks like now? Till here is heap, 4 elements are in a heap, and after 4th element, remaining elements are 5, 40 and 35. So 5, 40 and 35. These are yet to be inserted. Next is 5. Fifth step, insert 5. Where it will be in a tree? So this is the previous tree. Now we are including 5. So 5 comes here. Right? Now compare this 5 with the parent. This is the parent. So it's not greater than parent. So no change as it is. It is in its right place. So the array looks like this. So the array elements will be as it is 30, 25, 20, 10 and 5. Heap is till here 5 elements. And remaining 40 and 35 as it is. Next, insert next element 40. 40. When we are inserting 40, 40 gets inserted as a left child of 20. So I will draw it. So 40 is here. It will be compared with 20. So it is greater than 20. So it will be swapped. And further compared with the parent. So it is greater than 30 also. So 40 will move up until it reaches root. So 40 reaches root. And left side is not modified. At right side 30 comes here and 20 come as left child. So the resultant array, there is no space, I will draw it here. Elements in heap are 40, 25, 30, 10, 5, 20. And the last element remaining that has to be inserted is 35. So when this 40 was inserted, it was compared with the parent 6 by 2, that is 3. Then again its parent, that is 3 by 2 is 1. So it was compared like this and it was swapped. Now last element 35, where it will come? It will come as a right child of 30. So I'll show it here. So this is 35. 35 is newly inserted. It is compared with the parent. So it is bigger than this one, greater than this one. So it has to be swapped. And with its parent, no, it is not greater than that. So the resultant tree is, so this is a resultant tree, final heap, right? Final heap. So the elements in an array will be 40, 25, 35, 10, 5, 20, 30. So these are the elements in a heap. Finally, a heap is created. So you can observe that initially all the elements were simply given in an array. They were not in a heap. So we assume that first element is in a heap. Then we started taking the elements from right hand side and inserting them on left side. Like first 20, then 30, then 25, then 5, then 40, then finally 35. So one by one we have taken the element and inserted it on left hand side heap to create a heap, and all the adjustments are done in the same array A, right? Same array A. We don't need any extra array. Heap is created in place. So here I will write on the procedure for creating a heap. So here I have a function for creating a heap. So array of elements is with this function only. So I have an array. Starting index is 0, so there I did not use anything, I just kept a 0 there. So the elements are starting from index 1 onwards. This is index 0, this is 1, 2, 7. Then what I have to do, first element assume that it is in heap only. Second element insert, that is 20, insert, then 30, insert. So I should start from index 2. Insert an element index 2, and insert an element from index 3, then 4, then 5. So for that, I is taken here. I is starting from index 2 onwards and it's going up to index 7. Every time an element is inserted by comparing with the parent, so this is done by this insert function. So create heap is calling insert function by passing array and I. So first time I is 2. So this second element is inserted. I was 3. So this third element. I was 4. Fourth element will be inserted. Then when I becomes 5, fifth element, so sixth element, like this, all the elements will be inserted up to the last element 7. So major work is done there by insert function, but this create heap function is utilizing that function for creating a heap. How much it, so that's all about creating a heap. Now analysis, what is the time taken for creating a heap? Creating a heap means inserting the elements one by one. So for one element, what is the time taken? Log n. For n elements, how much time? N log n. So the time is n log n. So the time for creating a heap is n log n. See, all these things we have studied for max heap. If you want to change it for min heap, then just you have to change the condition. Temp is less than I by 2, just less than, then this becomes completely for min heap. So just change of condition will change the procedure for min heap. So as I said, what we are learning on max heap, same thing applies on min heap also. Now our next topic will be deletion from heap.